All right. Good evening. Um, sorry, I started a bit late today. Because I had something to sort out quickly. Anyways, so I prepared the list for today's session, and it's basically to go over everything I've solved so far. And also, there was a problem I remembered not solving, which is this check if a parenthesis can be a valid string. Um, Hold on. Check if a parenthesis string can be valid. This question is essentially a stack related question, and I've done stack the other week, so I'm just going to go over it again and see um, after all my research, right, if I'm able to solve this and explain it in a very intuitive way. So that's what I'm going to do today. I'm just going to solve this question and go over the previous question that I had solved before. So let me start with this valid. Check if a parenthesis can be valid, right? This question actually stressed me out. I'm not going to lie. I actually did something previously. I attempted this question and I just realized my implementation wasn't really good, but it was a good, first attempt. I mean, I think I passed all these cases here. If I run this, right, I passed the cases, but yeah, it wasn't really effective with other implementations. I mean, with other test cases, sorry. So I'm just going to, go over the problem again, read it, and actually understand what um is being asked in this question here. Okay, so um, I'll read the question again. It says a parenthesis string is a non-empty string consisting of only an opening parenthesis and a closing parenthesis, right? I'll call this right parenthesis and left parenthesis. So consisting of a right parenthesis and a left parenthesis, right? So it is valid if any of the following conditions is true, right? So when it is like this, when it has a left and a right parenthesis, right? This is valid, a valid parenthesis string. It can be written as A and B, right? A concatenated with B, where A and B are valid parenthesis string. So A concatenated with B, let me just open my board to the side. Right, so we have I just put it like this. Okay, so let me do this and that's okay. That's good already. So the string is a valid parenthesis string in these following conditions, right? So when the string is like this, when it's which is this one here, this part here, the first condition. So what this is a valid parenthesis string. In the case where it can be written as A concatenated with B, right, where A and B are valid parenthesis string. So A being a valid, if this is a valid parenthesis string X, right, A concatenated with B, right, where A is a valid parenthesis string, which means A could be in this form and B is also in this form. The representation will be something like this: A and then B, like this. So since it's a string, I'll just put it in, quotation mark. So this is what A concatenated with B means. It can be written as A, right, A inside the parenthesis, where A is a valid parenthesis string. So A like this is also equal to this like this, right? Which means it's also a valid parenthesis string. Now, you are given a parenthesis string s and a string a locked, right? Both of length n, so locked and the string s, right? Locked, I'll just come here. Locked, locked, the length of locked, right? I'll just put L locked is equal to the L of S. The length of the locked string is equal to the length of S is equal to N, right? So both of them have the same length. Locked is a binary string consisting of zeros and ones, right? For each index of locked, right? For each index of locked, if locked at I is 1, you cannot change S at I, right? So let's let me go ahead again and represent this other. I'll just scroll this to the top. Okay, that's good. So so these are the condition for the locked string. So when locked at I, right? I'll put locked at I, right, is equal to 1, right? Is equal to 1. It means S at I cannot change, right? So we know S is possibly an opening or a right parenthesis string or a left parenthesis string. This is left and right, sorry. A left parenthesis string and a right parenthesis string. So when we are locked at I, right, at this position here, and this value is 1, it means we can't change this here, right? This will be S at I. So assuming we are in our first iteration and I is equal to 0, right? I is equal to 0, meaning the first character in the string, right, which is an opening parenthesis in this case, right, is not going to be changed because the value of locked is equal to 1. Now, in the case, but but if locked is 0, you can change I to either an opening parenthesis or a closing parenthesis, right? So if locked is 0, we can manipulate this string, right? We can change it to an opening parenthesis or a closing parenthesis, right? Okay. Now return true if you can make S a valid parenthesis string. Otherwise, return false. So we've been given a table here, which basically represents um, what the conditions are for every locked index and every item at a certain position in the string S, right? So I'll just go ahead and use the first example and see how we can go about this. So let me just prove that I've not been able to solve this. So I've had like three wrong answers despite passing the test cases, which are like not the final stage of the question, right? There's no editorial for this, although I've looked at some solutions and they were not quite intuitive actually. So I'm just going to after doing my research and everything, I'm just going to use my own understanding to solve this question again. So here's what I'm going to do. So we have the string S, right? This is S here, and I'm just going to copy this condition here and widen my board. I'll just erase every other thing here and bring back whatever I had copied. So this is it here. All right, so our conditions are okay. So we already know when when the locked string is 0, right, we can change the position of we can change the direction of the parenthesis. We can change it to either left or right, or it doesn't matter, right? Let me just create a representation of our new string. I'll say it is going to be something like this, right? Now, or let me call this, instead of calling it S, I'll just call it res for results, right? Resulting string at the end. So when I'll call this res1, and res2, right? So this is result 1 and result 2. Okay, so in the first iteration when I is equal to 0, right, I'll just put I at this point. Okay, let me just, so I is equal to 0, right? I'll just do it this way. So when I is equal to 0, we are at this position here. So I is here, right? And also we want to look into the locked string as well. All right. So in this case, we know that in the first iteration, s s can be changed, right? It can be kept this way, or it can be changed into a closing parenthesis. So it's up to us to decide that, right? And there will be some factors based on which we have to do this operation, right? We have to make this switch. But for now, I'll just put the reason why I have these two results here is to just you know use the best possible um get the best possible result at the end, right? So here locked has a binary value of 0. The position of I in the locked string is 0, right? And the value here is also 0. So we know 0 means we can keep it this way. So response 1, I'll just keep it this way, or we can change it. So in the case where we change it, I'll keep it here like this, right? This is going to be a closing parenthesis, and I kept it open because that is what the condition in locked says. So when it's 0, it means we can change it or keep it the same way, but we can't just keep it the same way and change it twice in the same string, right? So we want to have a unique result at the end of the day. So when locked is 1, right? So I is at this position. I'll just move I to the right, right? So I'll move I to this position here and move this I to here, right? Now at this point, right, I is going to be equal to 1. So we are not really worried about the value of the index at this point. So I'm just going to put these pointers here. So at this point, we know, the string s at I, right? Si, or the the parenthesis string in s at this position here, I, right? When I is equal to 1 cannot change, right? We have to maintain it that way. So I'll keep it the same way here. I'll just put this here and I'll keep it here like this. So here is our second pair here, and we move I to the right again. We increase the value of I, we increment it in the next iteration. Now we are at 0, right? It means we can change the string or we'll keep it the way it is. So I'll just put this here again. This keeps it the way it is and this changes, right? So I'll keep it like this and I'll change it here, right? So we have closed and locked. So in the next iteration, I'll move I to the right and move this also to the right. So we increase it by 1. And the value here says the string at si must be locked, right? You can't change it. So we keep those values the same. We keep those values the same. I'll just keep this like this and keep this here like this. Okay, so that is 2, and we move again. We move this to this position here, right? So and move this to this point here. Now this means we can change, right? We can change, and we will also do the same thing again. We can change the position, the direction of the parenthesis in s at I, but here I said I'll just keep it the same. So I'll keep it like this, and I'll change the direction of this to like that, right? So now we have the last one. Oh, sorry, I said I will always make the change here. So I will switch this to like this, and the next time we move in the string, hold on. Okay, I said I'll make the switch, right? So we are this position here. All right, sorry, that's it. And we'll move this again by 1. So we are at this point, and we move this to this place here, and we are at this point here. This means we can also change, but the original string has to be kept the same, right? The first result one has to be the same, and I'll change this to this. Now, looking at these two results, right, we can see something. We notice a pattern, right? The pattern here is that this this string here, right? We kept this the way it was, so we don't really. I mean, I'm not going to cancel that out totally, but it's still relevant. Now, when we push this string here, right? When we push this string, uh, when we push this parenthesis into the result 2, right, we made a change, right? We switched the position of this one, and we kept this the same, but in the second case here we kept it normal. Now we can see that this here forms a valid parenthesis string, right? That is number 1. And in the second case, right, in the second case we chose to make a switch, right, in the result 2. And in result 1 here, sorry, I forgot to mention this, this is not valid, so we left that, so we are going to choose this instead. Now, in result 2, right, we also made a switch somewhere, right? So here we are the third position here, and the third string here is 0, right? So I also switch this direction of this, right? It means we can switch or we can keep it the same, right? So when you look at this, right, you see that, you know, the following string, if this can be switched, right, it means we can also put it in this direction like this, right? When we switch it into this direction, the following string here will match it, right? This is also valid, and which is what we observed here, right? So this is also valid. So we have a valid string when we make a switch, right? This value here is 3. So when we make a switch or we keep it the same way, it means, you know, the following parenthesis pair has to match it, right? Which is what we saw here. So this here matched whatever was whatever was before it, and whatever was before it is this string here, and the value in the locked string is 0. It means we can switch to make a matching pair, right? We can switch it or not, depending on what the following value is, right? So meaning we can switch it to create a valid parenthesis, which is what I crossed here, right? Now, when we are at this position here, right, when locked is equal to 0, it means we can switch this or keep it the same way, but we only want to do that when we know what the next value is, right? But I made the switch already because I know at the end of the day I'll make my, you know, comparison and see whatever was happening. So now here we have, you know, a closing parenthesis, right? This is okay. Every string has to start from a closing parenthesis to be valid in first place. So result 2 has a closing parenthesis. I mean, we don't really want to pay too much attention to whatever is happening in result 1, but hold on, I'm coming. Okay, so we don't really want to pay attention to not everything that is happening here, but like this is just to actually assert what the conditions we want to check here. So here we are this position here, right? This means this string could be like this or like this, depending on the value of the locked locked string here. So this is 0. So meaning it could be in this direction or this, right? So I already made the change. But when we look at the next item here, right? The next parenthesis here, this parenthesis here is also unlocked, right? I'll call it unlocked when it's 0. So it is also unlocked, with meaning we can change its position, right, depending on the value of this. So when we look here, we see this is opening, and I mean we can just change it to this, right? We can just change this value to this and match it with whatever was before it. So given the fact that we've gone through all the items in the string, and we matched every parenthesis to the previous one, it means we have a valid parenthesis string here, right? That is what this question is asking us to do. But how do we do this programmatically? How do we go through the string and validate each pair each time? So let me check in my stream. Okay, my stream is still going on. Cool. So for us to be able to do this, we need to really consider the the different um situations, right? So regardless of what happens, right? Regardless of what happens, we want to do something. So I I came across a solution where so my first implementation, I tried using stacks, which would have worked, but I think I implemented my stack wrongly. But you know, but from here, I think after explaining this, I will be able to implement the stack again. Um, but let me just go over this. Now, there will be some cases where we so what makes a valid parenthesis? A valid parenthesis string, right? Or a valid parenthesis on its own is a parenthesis uh a valid parenthesis string is a string that is made up of a right and a left parenthesis, right? Equal numbers of left and right, equal numbers. So if we had 5 openings, right? 5 openings, we must have 5 closing, right? It must be like this. So every time we go through the string, we have to cross check and check off everything. So corresponding values, that's condition number 1. Now what is another condition? Well, we know that we can create an opening, right, if the string is not locked, or we can even create a closing if the string is not locked. So how if the string is not locked? All right. So if the string is not locked, sorry, if the string is not locked, right? If the string is not locked, which means it's 0, we can create an opening, right? We can create an opening. If the string is not locked, we can create an opening despite the value of this here, right? We'll still need to create an opening. Whatever it is, whether it's an opening or a closing in the original string, we need to transform it into an opening, which is what I meant by creating an opening. We need to transform it into an opening regardless of what it is, right? And we need to keep the count of every opening parenthesis we have in our string, right? So meaning we can have like let's say, sorry, we can have opening 1 and keep incrementing this every time we see an opening, right? So in the case where we find an opening, right, in the case where we find an opening and the string is, in the case where we find a closing and the string is not locked, right, meaning locked at this position here is 0, then we'll transform it to an opening here, right? So in this case, we can say that this is a closing, right? This is a closing string, right? And the value here is a closing, this is a locked string, sorry. This is a locked string, and this value here is a closing parenthesis. Then it means here we want to, reduce this, right? We want to cancel this, so we cancel this like this. And in this case here, right? So when we are this position here, this is an opening, right? This is an opening, and this means this is also um, an unlocked string, right? We also want to keep it like that, right? We want to do everything in favor of this opening. So this here has to track the possible openings we can have, right? Every possible opening we can have. Now, when we see an opening like this, we want to transform it. When we see an unlocked string, regardless of what the value is, we want to keep it as an opening parenthesis. So we open this again, right? We are at this position here, and so in the next case here, this is locked, this is also locked. We cancel this out, right? So this comes back to 0, right? This comes back to 0, and we just want to make sure that we have, every uh opening parenthesis matching, or we have um every opening parenthesis with their corresponding closing parenthesis. So meaning the value of the opening parenthesis has to remain 0, because every time we find a pair, right, we reduce it. So this means it has been cancelled, this has been cancelled as well. Now here we have a closing, right? And whenever we see an unlocked string, we want to transform, right? We transform this to this, and whenever we have, so now we are at this position here, the last item in the string and the last one here. Now here we also need to change this to this, but now I already said we need to keep transforming in favor of the opening parenthesis. So when we do this like this, right, this will give us, a wrong answer, meaning we can't cancel this, right? These two can't match here. These two can't match. So what do we do in this case? Now, what we need to do is to have, a maximum parenthesis, a maximum opening parenthesis, and a minimum opening parenthesis. Now, a minimum opening parenthesis and the maximum opening parenthesis play two separate roles. Now, the maximum here, right, will play the role of this max open here, right? What does it do? This will contain every possible opening that we'll have, right? So in the case where the string is unlocked, right, we'll keep increasing the value of this maximum here. So we are only this like an optimistic way of validating an opening parenthesis string, or checking for an opening parenthesis. So we just want to make sure that regardless of the fact that the string is already opening, right, is already opening here. Let me just put it like this. Regardless of the fact that the string is already open and the locked value is 0 or 1, right, we always want to increase the maximum opening that we can have, that the possible maximum opening that we can have. Otherwise, we'll have a minimum opening, right? A minimum opening. I'll just put this min, right? Now, what this minimum opening does is, so given the fact that we kept increasing the maximum regardless of, whether the string is locked or unlocked, we also want to keep, an eye out for a possible locked or a possible left parenthesis that can be created from an unlocked string here, right? So which means that every time we see an unlocked string, right, 0 here, we want to decrease our minimum opening, right? We want to, which means it could be it could be transformed into a closing parenthesis, right? Unless we find a locked string that is an opening parenthesis, right, then we can increase our minimum minimum opening, right? This is just, you know, a situation where we are doubting that the unlocked string, could be anything. It could be an opening parenthesis or it could be a closing parenthesis. We are not sure yet. So we need to, increase and decrease in some cases. So the maximum parenthesis, maximum opening variable here keeps track of every opening we can possibly create, right? When the string is unlocked, right? When the string is unlocked and when the value here is an opening parenthesis. Now when the value is locked, right, when the string is locked and the value here is also an opening, we still keep increasing the maximum. But when the value is locked, right, and the value here, when the string is locked, right, and the parenthesis here is a closing parenthesis, we need to reduce the maximum, right? We reduce both maximum and minimum. Now, there might be a case where the minimum opening will reduce out to a negative number. We cannot have a negative parenthesis, so we need to keep the negative, the minimum opening at 0, right? We need to keep it at 0 always. Now, what condition makes this so let me say here, right, this place here, it looks like we are balancing every, here in this case we are balancing every possible opening and closing, right? So in the case where this is 0, right, this is exactly 0, this falls below 0, we need to set it to 0. But when our maximum goes below 0, right, our maximum can go below 0. When maximum goes below 0, right, it means we found too many closing parentheses that were reducing the openings, right? So we were matching more, we were closing more than we were opening. So it means in this case here, we just want to say the string is not a valid parenthesis string. But in the case where the minimum open, right, the minimum open is exactly 0, right, it means we've found every match possible, right? At the end of the iteration, it means we found every match possible, and now we are satisfied that we found a valid parenthesis string. But in the case where there's like one left, right, one left, it means there's one item in the string that was probably not matched. It could be a closing, it could be an opening. So and we already know that whenever we find an opening, we want to increase this minimum. But when we find a closing, right, that is locked, we want to decrease the minimum. When we find a closing that is locked and that is unlocked and the string here is a closing parenthesis, right, we want to reduce the minimum only. But if the value, regardless of what the value is at an unlocked string, we want to keep increasing our maximum opening. So I'll go over this again and explain properly. I think I just jumped through. Let me go over this again. So let me check my stream. Okay, got quite a number of people here. All right, that is good. That is very good. So let me just come here again and open this one here. I'll just, sorry. Let me bring this here. I want to open it side by side. Copy and paste. Sorry, I had a call. Sorry, 1 minute, 1 minute, 1 minute. I need to get this result. All right. I'm back again. Sorry for the break in transition. All right. So I'll just go over this again and explain why. Actually, I saw this solution on in the solutions list while I was researching a way to solve this, and the explanation wasn't quite clear to me, but I understand. I, you know, let me just show you the solution that it was. So I'll just come here. This wasn't it. I don't remember exactly what this solution was, but you know, no, this is not it. It was a solution. I think this is it. Mm, yeah, so this is the solution I was looking at. So see, is referring to the yes, potentially locked open parenthesis and seeming. Yeah, this was the solution here. This was the solution I was looking at, and you know, this wasn't quite clear, but I figured a way to you know, I mean, I read some other implementations, just trying to explain it as the way I understood it. So um, it's not bad to look at the solution. It's understanding the solution that is the main aim here, so that when you see other questions that are similar to that, you can recognize the pattern used and try to find a solution. So here's what I'm going to do. Okay, nobody's in the chat. All right, that's good. I don't have any questions to answer. All right, so I'm just going to you know take this back a notch and not rush through the explanation. So we have a string, right? A string that consists of parenthesis strings, right? And this string can be a valid parenthesis where every opening parenthesis has a corresponding closing parenthesis, right? So meaning you can create as many as you want, as long as they are valid, they match each other, right? This is a valid parenthesis. This will match that, this will match this, will match this will match that. Okay, that is one of the cases. Now, but there is an introduction of another condition where the string in the in S, right, can be locked or open. I'll say locked and unlocked, right? So it is locked. When it is locked, right, the value is 1, which means we cannot change it, right? We cannot change the position of that string. Now, when the value is 1, right, I want to create two variables that will keep track of every opening parenthesis. Now, I'll explain why I'm doing that. But first of all, we'll have a maximum opening, right? I'll call this max max opening, right? Max open and minimum open. Now, what roles do these two variables play? Now, the maximum open will keep track of every possible um, maximum openings we can have, right? Whether it is unlocked or locked. So when it is unlocked, right? So in this case here, right, we have S and the string is unlocked, right? It means here we can transform it to an opening. We can transform it like this. So maximum, these two strings here, they just want to keep track of every opening parenthesis. Now, when we find a closing parenthesis, right, that is locked, right, it means we want to cancel out whatever was there before, right? Whatever opening we had before. So we want to cancel that opening. So if we have a locked closing parenthesis, we'll cancel it out like this. And every time we find an unlocked opening or closing, we always want to transform it and increase the maximum parenthesis, right? The maximum opening here. But when it is locked and it is open, right? When it is locked and it is open, like in this case here, where is it locked and open? So this is 1, 2, 3, 4. So this is locked, right? Let's see where 1, 2, 3, 4. This is not open. So let's imagine the case where this here, right, was equal to 1, right? If this is equal to 1, then both are, both parentheses have to increase, right? We have to increase minimum and maximum by 1. So we put it here like this. But anytime we see an opening, right? Anytime we see an opening or a closing that is unlocked, we want to increase the maximum open. We want to put it in favor of the maximum opening. So we always want to have an opening each time. But in the case where we have a closing that is locked, right, that is equal to 1, we want to reduce the maximum, right? We want to cancel out every other value that was before it, every other opening that was before it. Now there might be a case where we have more locked closing than the maximum opening we created, and the same thing applies for the minimum open, right? So when we find a locked minimum, a locked a locked closing parenthesis, right, we also want to cancel that value as well, right? We want to cancel anything before it. Now, in the case where we find you know more locked than opening, right? More locked than opening, this value will certainly be equal, will be less than 0, right? This will be less than 0, meaning you know meaning we've had more closing parenthesis than opening, right? So we just return false. This is not going to be possible. We can't have more closing parenthesis than opening parenthesis, despite the fact that we are creating parentheses, opening parentheses in favor of the maximum. We cannot have more closing than opening. So this is going to be false. This case here is going to be false. We're just going to return false. Now, what happens in the minimum? Well, the minimum only increases, right, in the case where we have a locked opening, right? A locked opening. So let's say the locked value is 1 and the value in S is equal to this, right? Then a locked opening. So and the value is this, then we increase the minimum. Now when the value, sorry, my head is blocking this thing that I wrote here. I'll just shift it down here, right? Okay, why am I writing at the top when there's more space at the bottom? So when the value is locked, sorry, when the value is locked, right, and the string here, right, is a closing, right, is a closing, it means we want to match a previous opening, right? So we reduce this by 1. So we do this, we cancel this, right? It means we are reducing it by 1. Now, what other situation do we need to reduce this? Well, if the value here, right, is also unlocked, right, it means we can create an opening or a closing, right? It means we can create an opening or a closing. So we reduce this also by 1. So let's assume that we had a previous opening here. So and the value here is unlocked, right? So we can just reduce this by 1. So meaning we are now the reason why we need to do that is because here we are already increasing this in favor of of the max open, right? When the string is unlocked, we want to increase the max open regardless of what it is, whether it's been a closing unlocked parenthesis or an opening unlocked parenthesis. So whatever it is, we want to increase the maximum. But in the case where the string is unlocked, right, the string is like this, right, and the value of locked is 0, right. Given the fact that the value of locked is 0 already, we know that we are going to reduce the minimum opening. Now we can't reduce the minimum opening to below 0, right? We can't do this because we can't have negative negative opening parenthesis. This doesn't make sense. We always want to have 0 parenthesis, right? 0 parenthesis, meaning here we've already matched every value. So in the case where we even add, we keep seeing an opening, right, this will take the fall for that, right. This will always reduce for that case. So it means when this is below 0, right, when this goes below the 0, we can return false. But when we find a saturated amount, meaning the minimum opening is equal to 0, right, it means we cannot we've found every possible closing parenthesis for this case, and we can just return 0, right. 0, we can find out if the minimum at the end of the iteration is equal to 0 and return true or false. So that's it. That's it. And it's going to always be equal to 0. Otherwise, when maximum opening is less than 0, right, we'll return false in that iteration. So let me I'm not sure how I will explain this further without the code. So I'll just go ahead and implement this code now. Let me just come here, right. So here's my previous, okay, this to sum to what's this to sum to. Oh, okay, I saw two sum to yesterday and I didn't even push it. Oh, that's bad of me. Anyway, I'll push everything together today. Let me just commit this first. I'll just commit this. I'll just say git add git commit dash m to sum to sum to. Yeah. Okay. And I'll just create. I had it before, so it should be in stacks valid parenthesis can be valid parenthesis. Yeah. So this was my implementation. I think I solved this on day what? I don't remember, but it was one last week when I was solving stack questions. That tried this out, and my solution could only work for some cases, but it didn't work for other cases. So yeah, I'll just go ahead and delete this. You know what? I'm just stressing myself. Let me just take this out. Take everything and put it back here. Okay, so I want to use a string that is not a valid parenthesis, and explain this again, because this is a little tricky. you know it's tricky sometimes. So now in this case here, right, I'll just do this. In this case, hopefully I explained this really really well. uh are you sure? Yeah, I want to. I was doing that before. Why ask now? Okay, so here is my test case here. Now, I said I'll have a minimum opening and a maximum opening, right? A minimum opening is just going to assume that the string we're about to test now, if it's locked, right? If it's locked and it is an opening parenthesis, we can increase it. But if it's unlocked, then we want to reduce the minimum. But the maximum here always has to assume, right? Whatever the value is when it is unlocked, it is going to be an opening parenthesis, because we can change it, right? We can change it to an opening or a closing parenthesis when it's unlocked. But when it is locked and the value is a closing parenthesis, then we want to reduce it by 1. But if it is unlocked and the value is an opening parenthesis, we want to increase the minimum and the maximum, right? Because we know that they are always going to be I want to use another example. This example is okay. Let me just use this example and see. So in our first iteration, I is going to be equal to 0, obviously. So we're at this point here. Why is this huge? Wow, this is bigger than I thought. What's going on? Nah, this is. Is there anything I can do to reduce this? I don't know. Why is it big like that? Wait a minute. I don't know what happened. But yeah, let's say I is at this position here, right? And we are looking at this string. Now, the condition is such that our maximum opening, right? I'll just put max open, right? Max open has to increase regardless of whatever happens, right? Max open. You know what? Let me, since this has more diverse this thing, I'll just use this again. I don't I don't want to use the other one. I just want to explain this in the best way possible, right? So, sorry, bear with me, and I shall deliver. Okay, so we have this here. Oh, okay. I'll just use a blue color. All right. I don't know what happened. You know, the stroke just became bigger. So here we have I, and I is also going to be here because they have the same length. We can just track them with the same um, iterating index. So max open, right? Max open, and then minimum open. Now the condition is such that max open, when the value is an opening when the value is unlocked, right, which means locked is equal to 0, we can create an opening. We can transform it to an opening, right? That's what this states. Now, and the minimum has to be reduced by 1. Now, we don't have a minimum here, right, to even reduce it by 1. Meaning, okay, before we even reduce, this has to we are doing it in favor of the maximum. So we are transforming every possible unlocked string to an opening parenthesis, right? And when it is locked and open, we also increase the maximum opening. So in this case here, where I is equal to, when the locked string is 0 and this string here is um a closing parenthesis, it means we can change the direction, right? We can change maximum to either a closing parenthesis. We can change this. I'm just confusing myself. We can change this to either a closing parenthesis or an opening parenthesis. But since that flexibility is in place, right, it means we can, just go ahead and transform it to an opening, right? And the minimum here has to be, decreased by one because we want to add, a closing, right? We want to add, the opposite. But since we don't have any item here, we cannot reduce, you know, we cannot reduce an empty space by a closing parenthesis, right? So what we do here instead, we keep minimum at 0, right? We keep minimum at 0 even though we are decreasing. When we see a closing parenthesis, we want to increase by 1. So instead of putting this here, I'll just increase this by 1. So this is going to be equal to 1. So let me change the values to a different color instead. So I'll use this. This is going to be 1 and this is going to be 0. Now in the next iteration here, we are at this point here and this is 1, right? This is 1 and this is a closing parenthesis. It means we have to reduce both opening and closing again, right? Maximum opening has to be decreased by 1. So I'll do -1 and this will give us, this will give us 0. So I'll just erase this again. 1 minus 1 is equal to 0. So we erase that and set this to 0. This has to remain 0 because we cannot reduce an empty parenthesis, right? We cannot reduce that, so we keep it at 0. That's the minimum open parenthesis we can have. And this only increases in the case where we have an actual opening parenthesis, right, that is locked, right, and not unlocked cases. This tracks either locked and unlocked. So, and only reduces when the string is locked and the closing parenthesis. So in the next iteration, we're at this point, right? So at this point, we want to, this is an opening parenthesis. This is an unlocked string, sorry. And this is an opening parenthesis. Again, what do? We increase this one by 1. So we do +1. This is equal to 1. I don't want to do this here. Let me just erase this. So this is going to be equal to 1. Again, this can be transformed, right? So it means we can, reduce this by 1, and we don't want to do that. So we keep this at 0, right? We keep it at 0 still. So in the next iteration, we are at this point here. This is going to be equal to 1, and this is a closing parenthesis. So we again transform this to 0, and the next iteration, this is a closing, and this is an opening, right? This is a match. So this is going to be equal to 1. And this is going to increase again. So when we are at this point, this remains 0, so we can't even reduce 0 by 1 anymore, unless there's a value here. We'll reduce it by 1. So this will keep increasing. At the end, we'll have 2 here, 2 openings, right? Now this doesn't mean we necessarily have 2 openings. It means we have 2 possible 2 possible pairs, right? So I mean 2 possible parentheses that could form a valid parenthesis. So this can be transformed to this because the condition here states that we can change the direction, right? The condition here states that we can change the direction. So this can create a valid pair, right? Since this is equal to 0, right? Since this is equal to 0, it means we don't have any extra, any extra parenthesis that is locked. If we had something here like this, if this was 1, then it means this would have increased to 1, right? And the value here is 1 like this. This would have increased to 1, and we'll have the minimum open equal to 1, right? It means there's an extra opening parenthesis that doesn't have a match, and that means this case is invalid. So we are not going to validate it. But in the first condition, this string here is a valid parenthesis string because every opening parenthesis has a corresponding closing parenthesis, regardless of it being locked or unlocked. Let me see if I have any questions in the chat. No questions in the chat. All right, so I'll just go ahead and implement this in code again. So let me just leave there. So here is what I'm going to do. Now, first of all, I'm going to iterate I can iterate using the length of the you know, the string or the locked string. They are basically going to have the same length, which is according to the question, they are going to have the same length. Now, another thing we need to consider is the case where we have, you know, like in this case here, where we have, you know, an extra, you know, parenthesis. It could be closing, it could be an opening. We don't really care. But the point is, if we had a string like this, if we had an opening, a closing, and an opening like this is never going to be a valid parenthesis string, right? Because there will never be any string that will match this one here. So it means in this case where the string is has an odd length, right? It means, you know, not divisible by 2. Then we want to return false at that point. We don't even need to go through the string to see which one is, you know, locked or locked to find a valid pair, blah blah blah. We don't want to do that. So we only want to reduce we only want to check if the string is has an even length. Then we can go ahead and, you know, check all these cases here. Otherwise we just return false. So here's what I'm going to do. I'll just say now, before I even create my variable, right? So if the length, sorry, if the length of the string, right? So okay, so if the length is not divisible by 2, if not, right, length divisible by 2, so I'll just do this like this. Divisible by 2 is equal to 0, right? Then we just want to return false. Return false. I'll just show you. Oh Christ, what am I doing? So I'll just show you this, right? So let's just try an example here. In my playground, I always do this. So I'll come to the playground here and paste this. Instead of using len of s, I'll just use any number. I'll say 3, right? 3. If 3 is not divisible, so I'll just say print not even, right? Else I'll just say print even. Print even. So what do you think the answer will be? Obviously it's not going to be even. So yeah, we have not even here, right? So this basically it's a modulus operator, right? And if the number is divisible by 2, the remainder is going to be equal to 0. So here we are going to just run this. You can see this is even as well. All right, so yeah, so if the length of the string is not an even string, then we return 0. Now let's get to the main part of this solution here. So basically we are just going to run a for loop. So for I in, you know, we can use any number, so we can do range of the length of s, or even a locked string, whichever. It's still valid because they will have the same length. Now the first condition will be that if we have a locked string, right? So if locked at I, right? If it's locked, so I'll say locked is equal to, let's say, if it's equal to 0, right? It's going to be a yeah, it's going to be a string. So locked is equal to be 0. All right. If it's going to be if it's 0, right, it means we want to append items to the string, right? Or you know what? Let me start from 1. Right, let me start from 1. So if locked is 1, right? If locked is 1, and if the string is an opening parenthesis, we want to increase both minimum and maximum. So I'll create my minimum min open here is equal to min maximum. I mean max open, max open, and it is equal to 0. So this will have the same value. You can write this separately or just put them on the same line. It's also the same, right? Or even, you know, mean doing something like this is also valid. Mean open, right? Max open is equal to 0, 0. This is also valid. So whichever. All right. So now if our string at I, right? So if s at I, right, is an opening parenthesis, right? Is an opening parenthesis when this locked is equal to 1, right? So if it's like this, where is my opening? Yeah. If it's like that, sorry, this is an assignment operator. Sorry. Okay. So if it's like that, then we want to increase both maximum and minimum. So min open plus equal 1 and max open plus equal 1 as well. So we want to increase both of them. Let me leave some space here, some breathing space, so that you know. Right now, in the case where it is a closing parenthesis, right, it is a closing parenthesis, we want to decrease both of them. So minimum min open minus 1 and max open will also be reduced by 1. Now in the case where locked is the string is unlocked, right? So locked is equal to 0. I'll just put else here. Else, right? Else, when it's equal to 0, we still want to increase the maximum. We don't really care, right? So we still want to increase the maximum here. So I mean, maximum always has to increase, given the possibility of a mutation of the string. So we have to max open has to be increased by 1, so plus equal 1, and minimum open will be reduced by 1. Now min open will be reduced by 1, so minimum, okay, 1. Now I said that minimum has to remain 0, right? Minimum has to be, we cannot match a closing parenthesis to a negative opening, right? That doesn't even make sense. So we cannot have a negative opening parenthesis. So that's what we're going to do. So I'll just say minimum open, right? Minimum open has to remain between the range of 0 and a higher value. So min open should be equal to, right? Should be equal to the maximum value, right? Max of between 0, so I'll put 0 and the minimum open here, right? In the case where minimum open has been reduced here, so there are two places where minimum open could be reduced: when the value of the parenthesis string is is open, right? Is open, so locked is equal to 0, then we can reduce minimum string. Otherwise, when it is locked and the value is a closing parenthesis, we can also reduce it here. All right. Now, we don't want the case where we reduce the maximum below 0, right? If we reduce every maximum value to 0 and below 0, it means we have more closing parenthesis than opening. So let me just come here again. So in the case where we have something like this, in the case where we have this, and this, right, and we have 1, 2, 3, and the value here, right, for the locked, right, locked 1, 2, 3, 4. Even this means, let me just leave it like this: 1, 2, 3. Locked value is, let me just simulate something. This means we can transform. So we have 0, 0, right? Means we can transform 0, 0. I mean 0. I want to simulate something quickly. 0. This means it can be transformed. We can increase this, we can increase this, we can increase. This is locked, this will recruit locked. I want another. Yeah, I can put here this one, right? So I'll say this is going to be I just want to try and cancel. Okay, let me just remove this here. So I have locked, locked, unlocked, locked, 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 and unlocked again. Locked again. So this is going to be 0. Yeah, even if it's 0, 0, 0, 1, 1, 1, right? And then I can have like another locked here, right? And 1. So meaning this already, let's say 1, 2, 3, 4, 5, right? This is already 5, 6. Sorry, the length of this is 6. So this is a valid string to check every conditions for, right? So in this case, maximum will be increased by 1. Maximum can be increased here too. So this is going to be 2. In this place here, the string is locked, so we reduce maximum by 1, so maximum becomes 1 again. Here, the string is locked again. Maximum is also going to be equal to back to 0 when we reduce it by 1. And when we are at this point here, right, the value here is 1 also. Now we can't have like a negative string matching a closing, right? We can't have a negative opening, because at this point here, when we reduce maximum by 1, we'll have a negative value, right? Meaning there was no other string, right? There was no other opening left for us to match this one to, right? So meaning this will return false, right? This will return false. I'll keep this condition here and test it later. So this here, right, this is going to be false because there was no value in front of this, and this string is locked here. This one too is going to be locked, even though this one is locked, right? We can't have a locked closing string with a locked opening. This will never form a valid parenthesis, so we can't check for this condition here, right? So in the case where our in the case where our maximum value is below 0, then we have to return false, right? So return. So if we'll check another condition here, right? Come on. So if max open, sorry, if max open is less than 0, right? If it's less than 0, just return false. There's no need to go through the string again, just return false. Okay, and the final condition will be that minimum open remains 0 throughout the end of the iteration. So I'll just return right, yeah, minimum open is equal to 0. So let's test with a few string. I will just use my solution now. So let me create an instance of the solution class solution like this, and set it to equal to this solution class here, right? And let's print the solution here. Print solution dot can be valid, and my valid string is going to be this. Oh, I went to open a different browser. Come on, I'm not checking this, not now. Christ. So I'll just move to the side and use this as reference. So my first value, oh god, my first value to check is going to be this. So I have, let me use this delete code solutions first, delete code test cases first, and if it passes, then I'll check my own case here. So I'll just copy this and put it here like this, And the second one will be 0 1 0. Let me copy it again. I'll just copy this and paste it here. Now this condition is supposed to return true, so let's see what this is true, right? This is true, and means we pass the first test case. Let's see here, right? Let's see here like this, and 0. This should return false, right? Because it has an odd length. Let me see here. Let me just test another case, right? So here, oh, right, and put another 0 here. What do you think the answer should be, right? So this means we cannot, we'll increment maximum by 1 each time, right? Maximum is going to be incremented by 1 each time, but we will have to reduce, so this is going to be false. This is going to be false. What? Wait, hold on. Wait, it means here we are incrementing maximum by 1 and maximum by 1. So maximum is going to be 2 at the end of the iteration because we don't have any. And minimum value, okay, so this finished the loop and minimum value remains 0. Okay, sorry, that was my bad. And if I change this to 1, then this should return false, because here we can't change this again. But minimum, wait, this is locked. Okay, this is also true. This is also true. What am I saying? Okay, so wait, hold on. Maximum here is going to be increased by 1. Maximum is going to be increased by 1 as well. Here, maximum will be reduced by 1. So at the end of the loop, maximum is going to be equal to 0. And we said maximum, okay, false when maximum is less than 0. Okay, this is true. This is true. Okay, so the answer is false. All right, the answer is false because minimum here is not going to be equal to 0. Minimum here is going to be equal to 0, but maximum is going to fail here because maximum is going to be reduced by 1. Right? Is that it? Is that not it? Hold on. What am I saying? Wait. My condition is such that, let me just use this here. Hold on. My condition is such that when I have a closing parenthesis that is unlocked, right, I can increase maximum by 1 and increase and reduce minimum by 1, right? And reduce minimum by 1. But I don't want my minimum to be below 0, so I keep minimum at 0. Now, this is a closing parenthesis that is locked. So I increase minimum by 1. So in this case, minimum is equal to 1, which means there was, there was an opening that doesn't have a closing. So this is going to be equal to false. If I add this here, this is going to be equal to false just because that the length of this string is an odd string, right? So this is an odd string, this is false. If I add another one here, obviously this is going to be positive, so this is going to be true. Oh, sorry, we have more closing than opening, so I mean we have more string than the locked conditions here. So I'm just going to keep this as a possible opening, a locked, let me see, this is going to be, if I locked everything, right, if I locked everything, then this is going to be true, right? This is going to be true. If I opened everything, right, then something interesting happens. This means we can add this, right? Maximum increases, minimum remains at 0, right? Because we can't go below 0. Okay, maximum is going to be equal to 1. Maximum is going to increase at every count here, because every string here is possibly unlocked, right? It's unlocked, not possibly, but it's possibly it's possible to invert every character in the string here, right? Hold on. It's going to it's going to be unlocked. So the answer here is going to be true because minimum here, right, will never increase or reduce. Minimum will remain at 0. So this is going to be true. Yes, the answer is true. Okay, that is clear now. I was just confusing myself. And let me just use my own test case that I provided here, right? This one here. I'll test this here. I said this string is going to be what? Well, I didn't even write whatever I said here. But let me just validate this myself. So in this case here, right, the string is possibly unlocked, right? So maximum is going to be increased by 1. Maximum is going to be increased by 1. Let me use a different color. Maximum is going to be increased by 1. Minimum, so minimum here remains 0. Min 0. Oh, let me just call this min. Min is 0. Max is 1, right? So in the next iteration, right, the string is also unlocked. So maximum is going to be increased by 1. Minimum remains 0. So we have 2 now. Now the following strings, right, so here this is locked, so it is locked and it's a closing parenthesis, so we reduce maximum by 1. Maximum becomes 1 now, and minimum still will be reduced by 1, but we can't go below 1, so we keep it as 0. And here, right, here we are at this point here, and the string is still locked, so, and it's a closing parenthesis, so we reduce maximum by 1 again, so maximum becomes 0. So I will just do -1 here. So maximum becomes 0, minimum remains 0, right? Now in this case here, right, we are at this point here, it's still a locked string and a closing parenthesis, so we reduce maximum by 1 still, right? We reduce maximum by 1, which means we had more closing than previous openings, right? So maximum becomes -1, minimum remains 0, but the condition is such that when we find, when we have a negative maximum opening, that means there was more closing than opening, so this string will not be a valid parenthesis string. So let me just test this out again, and I'll test this in Leet's code later on. So I started with an opening, 2 openings, and then 1, 2, 3 closing, and then 1 last opening again. This is not valid because we have, so what are our values? Start from 0, 0, 1, 1, 1, 1. So let's run this. This will return false. Yeah. All right, that's the solution, and let's test this in Leet's code to see what the answer is. I'll just copy this, and okay, sorry, I didn't bring this back. This was my previous solution. I'll keep this here for reference. It's actually good to have tested something that did not work out, so we keep improving every day. So let me just run this again for every test cases. So like previously, I passed every test cases, but the solution was wrong. So let me submit this. I've not solved this before, but I'm just sure that it's going to work. Please work. It's taking long. Okay, it actually did work. The solution, the runtime is quite low, right? Okay, so let's see what's the reason why it's low. Because we are calculating, we are not creating more memory in we are not creating more memory in our code, right? We are not increasing the space complexity. So our the space complexity is linear, right? It's based on the input of the string, the length of the string here, so it's going to be linear. And I don't know why, for the time complexity, right, it means how many time each solution, each expression in the string, right? So this here is an expression, this here is an expression, runs, right? It's also going to run based on the amount of input, so this has to be linear as well, right? Let me refresh this again. I also want to use stacks to solve this question, but I'm running out of time, so I'll just go ahead and submit this again. I want to use stacks to solve it, and I believe stack will solve this question so well. Well, I think the runtime value will never decrease. So this is okay like this. So I'm not just going to. There's another valid parenthesis string question. Generate parenthesis. What what is going on here? So there are so many parenthesis string questions. And what is this? Backtracking. I think I've solved like three parenthesis question right now, and let me just come here and see. So I have um valid parenthesis, right? If the parenthesis is valid, yeah, maximum nesting depth. So I solved this, which was really good question. Um, so this is also a parenthesis string where we find out, how deep, how nested each parenthesis string is. Valid parenthesis string is. So there's another one again called what? This. Let me see. I still have 6 minutes, and I have other questions to go over. Um, let me look at my chat. Okay, nothing much is going on in the chat. So, oh, okay. There were people in the chat. Sorry. Oh, wow. Nice, nice, nice. All right. Good evening. Good evening. I remember doing this once in an actual interval. Good luck, pal. Thank you very much. Thank you, Martin. Thank you. Um. Okay. I think so far, so good. So far, so good. I think I need to keep track of every parenthesis related question that I solve. You know, just to uh come back to it again. And solving a question once means you can solve the question, but like, can you how will you be able to how fast will you be able to remember the technique used, right? And that factor is going to be based on how much you solve the question, how much you repeated the question, you solved it, what patterns you see. There is an element of memorization in everything we do, right? Like, I follow Neat Code a lot, and he always advises you actually memorize some things, right? You need to memorize some things in order for you to recognize that pattern in other in other questions, in other problems, for you to be able to solve them. So there is a good reason why you should memorize some things, right? There's a good reason why you should memorize some things. So, and solving the same question over and over again will just keep that inside you, and you will remember whatever it is that you did previously. So in my description, I actually added that go over I'll go over some question I have set before. So let me just some question I had solved, sorry, before. So the two sum two was the question I did yesterday. Find the index. Yes, this question is so good. It is so, and it's okay. Find the index. I didn't even remember solving this question, and I think I did it just yesterday, right? Index of the first occurrence. Was it not yesterday? Yeah, it was yesterday that I did it. So, and this question, when I read it again, I'll just remember how I did it, right? It is it is looking for a needle in a haystack, and we are going to use two pointers to solve this question, which is actually cool, right? It's a really nice question, and I'll just go over it and explain how to do it again. This is just bonus question of the session. um even after the stream, right, I still go back over these questions and solve them once more, solve really, similar questions. And I think I should just be sharing the questions I've been solving, the ones I solve live, and, for anyone who is also studying to follow through with me as well. So we are on the same journey together, right? So let's go back and this valid. There's another valid parenthesis string question, and this is also a medium question. Even a string s containing. Okay, let me not deviate from the original objective. So I'll just come here and solve this question again. So I'll just shift this to the top. Now we are looking for a needle in a haystack. This is a very interesting question. I think, you know what, it's not bad. Let me just use this solution, because this you we will immediately find the position here. I don't want that to happen. I want a much more difficult one to find. I will just look at this one here. Leads code. You know what, let's change the needle here, right? I'll change the needle to, where's my board? I'll change the needle to a different string, right? We'll have the needle as a different string and not this anymore. It's not going to be sad. I'll just change this. I'll change it to something else. Come on. I'll change it to this. I'll change it to but like this, right? Okay. So now we have the needle somewhere else, which is good. Now, what's is the way to solve this question? It is actually, not straightforward. I will not say this question was straightforward for me, at least. So here's what I did, right? After reading and trying multiple tries. So first of all, we need to make sure that we are looking. Let me just add 5 more minutes to my time. I'll just turn this to 10, right? 10 at least to be safe. Okay, so we are looking for a needle in a haystack. Basically, we are looking for a string in a larger string, right? So, like, it's just going to act like a substring of that string. Now, to be able to do that, we need to have 2 pointers, right? A pointer that, starts from a certain position. So I'll say a left and right pointer. So my left pointer is going to be here, and my right pointer will increase through the string as much as we want, right? Now, as much as we want is wrong. We want to increase as much as the length of our needle here, right? So we need to make sure that the right pointer only increases as long as the length of this needle string here. Oh my god, as long as the length of this needle string here, right? We don't want to go beyond it. So yeah, that's what we need to do. And now, how do we even start this? First of all, we need to start our left pointer here and have a right pointer at the same position, right? Now, the right pointer is just going to check for the values just going to compare the values in the needle string. So in this case here, right, we'll have haystack. I'll just represent it with h at r, right? We'll compare it with arrow is basically the right pointer, and the L is equal to left pointer. Needle, I'll represent needle by N at R, right? Now, in the first iteration, right, we are going to use the length of this needle string, right? We are going to use the length. So the range is going to start from 0 all the way to the length of the needle string, right? So in our first iteration, HR is going to be equal to S, and needle is needle at R, N at R is going to be B. So immediately we know this don't match, right? S is not equal to B. So we increase the, you know, the left pointer towards the right, right? So we move it towards the right. So we just stop. There's no need for us to even continue checking for the remainder of the values, right? There's no need for us to go N at arrow within the same iteration, right? Where the left pointer is equal to S. So we increase this again by 1. So I'll just, where's my this? So I'll increase the left pointer. Oh my god. So let me just erase this. I'll just erase it, and I'll increase my left pointer here. So my left pointer is going to start here, and my right pointer too is going to start at the same position. The reason why I'm starting at the same position is to just, you know, I'll just get to that point here. I'll not tell you now, but let's just keep watching. Oh, I can still tell you, because the left pointer is going to keep the index at which the match started occurring, right? We want to return that index, the first occurrence of the needle in the haystack. So here we'll start R here again. R is going to be there, and we'll go through again. So in the iteration, yeah, we'll compare each value at R. So in this case here, R is going to be A. R is not equal to this. R is not the same as B, right? So we cancel this iteration. Let me just cancel this. We cancel this iteration. We move the left pointer towards the right. So now the left pointer will be at this oh, what's happening? Now the left pointer is going to be at this position. The right pointer is going to be here. We'll compare the values again. It's not the same, but we'll still move the left pointer again. We'll move left pointer towards the right, and the right pointer towards the right. So we'll increment left pointer each time the value doesn't match the, you know, the value in the needle. Each time the letter at this position doesn't match the letter at this position here. So arrow is going to also point at this place here. Let me just, sorry, R is going to also point here. So that's the value of R there, right? Now we see a match, right? When we see a match, we'll then compare, right? This is equal to that, right? So S at R, let me just erase this quickly. So we'll go into the string again and start comparing, right? We'll compare the position at HR, right? This is going to be B, and this is the first iteration. B is also B here, and then we have U. So the right pointer would have moved by 1. It would have moved towards the, now the left pointer remains here when we found a match, right? The right pointer would have moved by 1 again, right? So we are at U, so the value here is going to be equal to U, and then U is also here when we move the right pointer to this point. So I'll just change this to here. I'll move it here, and then R is going to increment again, and the right pointer in the needle also is going to increment. We'll have T, oh Christ, we'll have T here and another T here. Now we found every possible match, because we cannot continue incrementing this, because we are at the end of the you know, we are at the end of this this needle here. The iteration is going to end here, right? Because this is going to be, so I is going to be equal to 0, then 1, and then 2, right? The length of this string here is going to be 3, and we know we can loop from 0 all the way to 2 and not 3, because 3 is no longer part of, 3 is outside of the range, right? The index is wrong at that point. So we then return the value of L, right? The left pointer here. The left pointer would have been here, let's say 0, 1, 2, and 3. So the left pointer is at this position, and this value, this is the value we return, right? We return the left pointer here, which is equal to 3. If we don't find a match, we just return -1, right? That means we don't have the needle in the haystack. And when the length of the needle is larger than the haystack, then we return -1 as well, because we can't look for a larger needle in a smaller haystack. Yeah, so that's about it for, you know, and this is the Python solution for that. I think I have it. Find the first occurrence. Yeah, it says it's an easy question, but it wasn't easy for me. I had to, go and research this and understand what the question is about before I was able to solve it. All right, and if I show you here, I think I made a couple of mistakes. Um, yeah, I made a couple of mistakes. So you can see I did not solve this until the following day, right? Even the following day, my first attempt was wrong. Um, my first attempt was wrong. So yeah, it was good. It was good. Um, you know, I tried this. This is my solution at first, which did not work. So I had to try it again. And you can go to my GitHub to get all of these solutions. I arranged them in terms of topic. Um, yeah, so we have all stacks, arrays related question, stack related question, two pointers related question, and so on. I think for the two pointers, I solved two mediums question, but I will solve more questions outside and push them to GitHub as well with some explanation actually, and right, so that's it for the two pointers. Which other topic do I have in uh, the um? So I have two sum two, right? Two sum two was also quite easy. We did not need to do much for two sum two, but let me just go ahead and explain two sum two. Two sum two is actually a very good question. I'm just going to copy the link again. Let me copy it from here. Find the two sum two. Yeah, so this is two sum two here. I think two sum two was also a medium question. Two sum two is also a medium question. Two sum one and two sum two, they are all similar questions, right? My time is almost up. But there's I'll just go ahead and explain two sum two before I go. So two sum two, we have you know numbers sorted in non-decreasing order, like Liquid used likes to say. What that basically means is that the numbers are sorted in an increasing order, which means we have a smaller to a bigger number. So in this two sum two here, what we do is to have two pointer at both ends, right? So we have a pointer at the beginning, which is the left pointer, and a pointer at the end, which is the right pointer. So let me just illustrate that. This is better illustrated than just looking at the code. Oh, so I'll just come here and increase this again. So what happens in this case here? Oh, okay. So I'll just change this to this. So our left pointer is going to be here. I will represent this string in a much bigger way. So I'll represent this. Okay. I'll write it out again just to make it bigger. 2, 7, 11, and 15. Right. So we'll have a left pointer here and a right pointer here. Now we already know that this is sorted, which is why we put our pointers at each end, right? If it wasn't sorted, then we might just put the pointers following each other. Otherwise we can just do it this way. So when it is sorted, we know we can just find we will make we'll add the value at the left pointer to that of the right pointer, and when the result is bigger, right, we then know that we have to decrease our right pointer. So what do I mean by that? So um numbers, I will represent numbers by num. I will say num at L, right? So this is result. I'll put this as result. Num at L plus num at R, right? Num at L plus num at R. In the first iteration, right, num at L here is equal to 2, 2 plus 15, right? This is not going to be equal to the target because this is equal to 17. So here we know 17 is bigger than the target. So what do we do in that case? We'll move our right pointer to the left, right? So we'll decrease it by 1. So I'll just move it from here to this part here. I knew I just did something wrong. So let me just try and select everything. Okay. and move it here. So our right pointer is going to be here. In this case, if we do 3 plus 2, I mean 11 plus 2, this is going to be equal to 13. 13 is not equal to 19. 13 is still bigger than 19. So we will decrease our right pointer to the left. We'll move our right pointer to the left by one position. Then, in this case here, we have 7 plus 2, which is equal to 9. So this is equal to 9, and we can return the position at the values of the left and right pointer, which is equal to 0 and 1. But the question asked us to return it this way, right? So we are going to add 1 to each, right? So we are going to add, so even though this was 0 and 1, we just do plus 1 plus 1, which is what I did here. So left plus 1, right plus 1 here, which was, us, it was awesome. It's quite, I think I solved this the same day. I did not have, yeah, I solved this the same day. I did not need to, you know, um, yeah, it was a good solution as well. It was a good solution as well. Yeah, sometimes we find the solution, sometimes we don't. So we have to go and study more and um, look for ways to pass that particular question, which is actually nice. And then our advice, anytime you solve these questions, you just go over them again and try to solve them once more and try to explain them to yourself. So this question today was quite um where was it? Check if, but yeah, this question today. I'll still go over this again by myself and see how best possible I can still solve this question, right? And what exactly was the reason why I was doing certain things, and try to improve each time. Um, yeah. So the point is to just get better one by 1% every day and solve more questions every day. So I'll just go ahead and push this to GitHub. My solution today was can be valid parentheses. So here we have, this is my terminal here. So I'll just do git add like this, git commit dash m can be valid parentheses. I'll just put parentheses like this. Okay. And yeah, so that's it. And I will push this to GitHub. So hold on. Okay. So git push origin, origin main Christ. All right. So all of these questions are on GitHub. The link is in the description below. You can take them and try to solve them as well. That's it for today, and I'll see you guys tomorrow. Okay. I hope we are all learning and growing every day. Ciao. Ciao, ciao.